spiral matrix. We will trace the clockwise path, move one boundary at a time, and build the answer in the exact order cells are visited. First, let us make the question completely clear. The input has 3 rows and 3 columns. Start at the top left cell and visit every cell once in clockwise spiral order. Clockwise means move across the top, down the right side, back across the bottom, and up the left side. Then repeat inside. The expected output is 1, 2, 3, 6, 9, 8, 7, 4, 5. We return this list of values in visit order. The matrix itself is not changed. Build the matrix row by row. Each value stays inside its row and column. No cells have been visited yet. The traversal will begin at cell 0, 0, the top left corner. Instead of remembering a complicated path, keep 4 boundaries around the cells that are still unvisited. Top starts at row 0 and bottom starts at row 2. Left starts at column 0 and right starts at column 2. These 4 numbers describe the current rectangle. After finishing one edge, move only that edge inward. The remaining rectangle is the next layer. Move the arrow right to cell 0, 0. Put 1 into the next output slot. Move the arrow right to cell 0, 1. Put 2 into the next output slot. Move the arrow right to cell 0, 2. Put 3 into the next output slot. This finishes the top edge, so top moves from 0 to 1. Move the arrow down to cell 1, 2. Put 6 into the next output slot. Move the arrow down to cell 2, 2. Put 9 into the next output slot. This finishes the right edge, so right moves from 2 to 1. Move the arrow left to cell 2, 1. Put 8 into the next output slot. Move the arrow left to cell 2, 0. Put 7 into the next output slot. This finishes the bottom edge, so bottom moves from 2 to 1. Move the arrow up to cell 1, 0. Put 4 into the next output slot. This finishes the left edge, so left moves from 0 to 1. The complete outer ring fades into the background. Only the inner rectangle remains unvisited. All 4 boundaries have moved inward. On this 3 by 3 example, they now meet at the center cell. Now repeat the same clockwise rule on this smaller window. This is why we describe the algorithm as peeling layers. Move the arrow right to cell 1, 1. Put 5 into the next output slot. This finishes the top edge, so top moves from 1 to 2. After a boundary moves, the remaining rectangle may disappear. Check that it still exists before walking the bottom row or left column. Top less than or equal to bottom means at least one unvisited row remains. Left less than or equal to right means at least one unvisited column remains. If either check fails, skip that edge. This prevents the center row or center column from being appended twice. Every cell has been visited exactly once, and the bright trail shows the complete clockwise spiral. Return 1, 2, 3, 6, 9, 8, 7, 4, 5. The output ribbon matches the order of the path. Each matrix cell is processed once, so the time is O of rows times columns. The only extra storage is the required output list. For a single row, walk from left to right once. The row guard then fails, so no reverse pass repeats those values. For a single column, walk from top to bottom once. The column guard then fails, so no upward pass repeats the column. A rectangular matrix needs no new idea. The same 4 boundaries shrink until no unvisited rectangle remains. Here is a natural interview explanation. Keep 4 boundaries around the unvisited rectangle. Traverse the top row, right column, bottom row, and left column in clockwise order. After each edge, move only its boundary inward and check that the rectangle still exists. Every cell is appended once, giving O of rows times columns time. Create the output list and place top, bottom, left, and right around the full matrix. While a valid rectangle remains, append the top row from left to right, then move top down. Append the right column from top to bottom, then move right one column inward. Only if the rectangle still exists, walk the bottom right to left and the left side bottom to top. These checks prevent duplicate visits. When the boundaries cross, every cell has been appended once. Return the spiral order in O, rows times columns time.